Now or
Wow, it's excellent. It's excellent. Thank you so much.
okay, very nice. Let me share my screen. Oh,
All right. Oh, great. Yes, we can see your screen. Yeah.
okay, very good.
Thank you so much.
Okay, let's get started. So, I was talking about, we'll go through some of the more focus on these, how to implementation of AI, then start going through the uh, with the very basic stuff here. As you are already working on this field, you know this. Machine learning is a bunch of artificial intelligence and all those. But what is important here is there are a lot of sub-vertical within machine learning, and we call it artificial narrow intelligence. That means it's solving a very narrow set of problems. For example, medical imaging or image recognition in general. Then we have fields like speech processing, language processing, and then just working with the structured data like classification, clustering, etc. So those are also important. So I think here the point is we are going to focus on the narrow task, and that's really what is important to understand from the business perspective as well. When you choose your project, we generally focus on solving a very narrow problem than just saying AI can do pretty much everything in the world. That's a high that's probably not true. And in general, the way we look at this paradigm is like a new computer paradigm. It is not just doing data analysis. It's a way we're going to program the computer in the future. Because previously, we just focused mainly on the left-hand side, which is basically a symbolic thing, algorithms that are created by the human. And then what you're focusing on as a part of machine learning and AI space is getting into algorithm learning from data, learning from experience, and creating some of those equation automatically behind the scene to solve the moving more towards the right. Of course, you need some of this left-hand side as well because tasks are good for machine learning types of approach. There are types of machine learning, and today we're going to focus mainly on the supervised machine learning. There are unsupervised machine learning, and there are reinforcement learning, which is a relatively new field, and there's a lot of research going on in that area. Supervised machine learning is like you have inputs and then you have some outputs. You want to detect whether the image is a cat image or not. You have image on the left side, and you have some kind of architecture, the neural network architecture, and you have the thing. There are problems that looks very similar to this, like spam filtering, audio classification, speech recognition, or machine translation, or radiology. So all of the areas where you can apply supervised machine learning type of problems. And most of the projects going on in the world right now is a supervised machine learning problem. Why you were talking about deep learning and in general today, or nowadays. Uh, this is deep learning is not new. It's a kind of a new name, but it started a long time ago in 1960s. A collection of mathematical units organized in layer that can work together to solve or model a complicated task. In general, smaller data sets or limited compute, uh, it generally doesn't that well. But nowadays, you have lot of computers, you have cloud, and you can have unlimited computers in many cases, and a lot of data, a lot of more services are creating a lot of data. So that's why it creates opportunity for neural network now to do interesting things that previously they were not able to do. So now proven that most of the traditional approaches, has some limits of the accuracy and scaling. While neural networks can be more accurate, the models that are developed using neural networks are much accurate, and they can tell data set and model more model size, what the other methods could do. The key benefit is accuracy. Learning can learn from the raw data without doing explicit feature engineering. Because the other requires a lot of feature engineering, hand-coded feature engineering work, and machine learning using deep learning requires less feature engineering. And this is also, I taken this image from a Coursera deep learning.ai, and they talk about exactly the same. Because of the large neural net, now we can have a significant level of performance improvement than we previously have seen. And this creates to rebalance a lot of the effort. In traditionally, in machine logic, we have more and more work in featuring. We get the data, we prepare the data, but then we spend significant amount of time in doing feature engineering. So now with deep learning, we'll be spending more and more time on featuring and just and actually the model architecture. That means understanding how to actually layer the various neural network rather than spending too much time on actually creating the explicit features, because a neural network is going to help us filter a lot of the features by the design. And this is a rule of how much data is good enough data. We have seen in a lot of cases, even the hundreds training records could have good model. So in this 5,000, but not mostly the general case, but we could do even with less records. And there's a lot of research going on right now to make significant improvement in that area, because a lot of the industries, like healthcare, let's say in a healthcare in rare disease classification problem, you may not have a lot of data, but a research that field is where we are creating data now, create data to match the machine learning problem that area. In the area of image recognition, there's a lot of work going on right now to create this kind of data that could be utilized for machine learning training purposes. There's a little bit on the unsupervised machine learning, where it's mostly about visualization of a very high level data or of the data. When you have a new data that you check, the first is in that. So the first thing that is to do a clustering on the data, just to understand what are some of the attributes. Writing an explicit sequence, you can do class as a step to identify the of your patient. For example, do a disease classification project on a population of patients. Before you understand the representations, so like what type of you have in the data, conditions, sets, whether you have the right sample. As a clustering ways, you those things. So it's automatically going to segregate it so that you can now look at a cluster to identify your or the sample that to just do some analysis on those to see the trend, etc. So that's a way to use, but there are other. So how do we kind of some of the on forecast, to classify, to recommend, then it's mostly about and the concept of machine learning about doing segmentations or doing class. So I actually TensorFlow. So TensorFlow is one of the you'll be using to this and open industry forward and contribution from many across the world, not just Google. For design, one of the key things is it not only on the cloud, but it runs in your machine and your desktop devices as well. You should be able to deploy across the board because let's say who is using device, there is a may not access that. So there's a lot of available to make a concept called type that can.
Dr. Adrish, excuse me, please. Hello, can you hear me?
Yeah.
Yeah, it seems your network started to break again, so it's a little difficult to follow along.
Oh, you are okay. You're not okay. And generally use thing here. Oh,
Hello, Dr. Arisha. Are you still there?
just trying to see if I can change anything on the settings in the Zoom. Zoom is a Google Meet, so it is do in the settings to make sure that. Give me one moment.
Okay,
So meeting control. I have internet 200 Mbps, so this is not a problem with my internet because 200 Mbps is I don't see any change here in the Zoom because it's pretty much everything is an audio. Is it better?
Oh, I'm afraid it's not so better. Like, I can't even hear you at all.
Yeah, it's showing me 120 Mbps.
Hello, do you think it might help to try to reconnect again? Hi everyone. I see a lot of chat in the chat section. Hi, can you hear me? Can you hear the hi? Hello? Okay, so
Hello, we can hear you.
while we wait for Dr. Adrish to fix the connection issues, apologies and apologies. I believe we all know that these kind of things can happen. I see a lot of it doesn't happen in Nigeria a lot in the chat section. So but he's working to fix it. So let's hold on a bit. So Dr. Adrish just left the call now. I think he's going to join again. Yes, he's trying to connect again. Someone said maybe we should all disconnect and connect again. Could it be it's all of our networks and not his? Please let's give him a moment. Thank you.
When am I?
Hello?
Great. Yes, we can hear you.
Okay, I think it's a little bit better now. Sorry for all the interruption. I don't know what's going on. Can you see my screen?
Yes, we can see your screen.
Okay.
I can screen, sir.
Very good.
Okay.
Okay, so let me go to the. We are. I think we're here. Okay, TensorFlow. So now let's. And you can learn about TensorFlow by going to tensorflow.org, and there's a significant amount of documentation there. But in the industry today, most of the practitioners are not using the base version of TensorFlow. Started using some of the libraries that is available. So you probably heard of Keras, and Keras is one of the popular, probably the most popular APIs that's available on top of TensorFlow, so that like most of the folks who may not be able to do the lower level math-like programming can still start with Keras. And there are other kinds of tools available, but this is the most popular tool that you're using in possibly in your environment. And now let's talk about a little bit about some of the machine learning examples. See the applications that we have in our environment. And you can see that 2012, there is not much machine learning models in most of the Google applications. But now it is, in 2016, it's 4,000. I'm sure now it is probably crossed 10,000. I don't know exact number, but it's a significant. And it's used across multiple products, the products that you're probably using, YouTube, email, maps, etc. Everywhere, machine learning is the way we kind of program our applications nowadays, and we are calling it AI first company. So any problem we want to through how the problem could be solved using machine learning approaches than the traditional computer algorithms approach. And this is an example of that. It's called feed-forward neural network, which is used for some of the spam applications. And then Google Photos for search personal photos without tags. So you can do that because of a lot of the machine learning training that is happening behind the scene. And then the Waymo of his self-driving car is a significant applications of a machine learning. There are lots of model within this self-driving car element. And then a lot of us uses Google Translate when you travel, and that's a application of machine learning in the supervised machine learning space. It's now 132 different languages. Now I'm going to talk about a little bit about an application that Google Health or Google Brain team did on healthcare. This is one of the first application of Google technologies or Google machine learning done by Google within Google for a use case which is outside of technology of use case. Because other use cases that you see before is kind of a technology case, Gmail, etc. Here, we are talking about a condition called diabetic retinopathy, which is a blindness in a diabetic patients. It's one of the fastest growing cause of blindness across the world. You can see Africa, the number is 14.2 million right now. and then projected to be 34.2 million. So this is a so how it is diagnosed? It is mainly diagnosed taking a photo of your retina, and then a radiology or ophthalmology that that person goes and try to find radiations of retinopathy, and it range from no DR to mild DR, moderate DR, severe DR, operative DR. So these are the things, these are the classification that could happen from this image. So how we did this work, we used a significant number of from India and some parts of the States, and we manually label them using a lot of radiologists' time. And we have a variations. No, we just didn't took the radiologists from one particular institution. We took from various institutions within the US, and then they model. They don't train the model, they label that. So once they the data, we apply a concept of convolutional neural network, which is one of the variations of neural network, which is previously developed within Google to basic stuff like differentiating between dogs and cats images. But now it's the same image processing algorithm and applied for retina detection. And we have significant I'm going to just see what happened. But this is a 26 layer of convolutional network and variety of convolution pooling, etc. But the result was very significant because algorithm achieved F score of 0.95, which is case is actually same or better than the radiologist or ophthalmologist. So this algorithm achieved the performance level close to a human doctor. And that has a lot of implications and how you can use this medical department. Now let's talk about how do you actually use this technology. Now you prove it that this is useful. Something performance or performance than human. So how do you use it for practical purposes? Why you want to use it? You want to use it because a lot of facilities doctor. This could be a doctor who has some understanding of the disease or understanding of the patient, but main expert in all reading of the future, but the decision actually it helped them scale with having too many, because that's in many countries, even in the United States, not have all the sub disease condition. That is one of the of machine learning. I think would be where we can utilize for the is available. hospital systems for exactly this technology can now implement things. You can create maybe can now who could have they can hire some they could be retinopathy types of condition. It's not only it's one of the things could be in the could be in the office, or it could be a office in a things. Thinking maybe a mall kind of other now can start the detection business from scratch. Technology now, but to other doctors, understanding of not a real life example of how you can move a action setting.
That's why it's not the closure. That's why
Hi, Dr. Adrish, are you there? Hello, can you hear me? Dr. Adrish, if you can hear me, I can't hear you at all.
Okay. Alima, can you hear me clearly?
Where I can hear.
Okay, I think it's high time you muted everyone. Your message. Okay, sorry everyone about the network, but I guess this happens to all of us. Nuruddin, sorry about that. We were all looking forward to this too. And nobody loves this. Nobody loves when this happens, but it's joined again. So please kindly stay online so that we can continue our class. So sorry, team, especially people joining from their phones, from wherever. Oluwatimileyin, you didn't say that. I'll pretend not to see that, Milaine. He will come back online. And for everyone looking forward to this, definitely, like we've shared for all classes, we are going to share the presentation with everyone that is registered for this boot camp. At the end of the boot camp, the videos, the slides, it will be ready. So I think we can make do with that. For people in anomaly detection class, your room is open. Okay, so it's going to come back online, definitely. Joshua, thank you for the feedback. Everyone, definitely this was not planned. Yes, we hope so too. We hope it comes back online. But like I said, everyone will have access to the slides, to the presentation slides at the end of the boot camp. Okay, I can see reunions going on in the chat window. While we wait for Dr. Adrish, it's an opportunity. We're in person, people usually take the slide and decide to say hello. Let's note up or something. Okay, so community reunion. This would have been a good time for us to take a small chops break. But like I said, it's online. Yes, Dr. Adrish will join back. Okay, but the people are doing reunion in the chat window. It's okay. Oh, well, I need this. We're allowed that is talking. No small chops for virtual meeting. It's only in-person meetings that we have small chops. No small chops. Buy chin chin or popcorn. It's Wurala speaking, not Chinazo. Alima, are you online? They are asking for anybody small chops. I don't have a big tag. Ernest, why are you? This is so unfair. Hello, Alima, see implications in the chat window.
Yes, I can see that.
Isaiah, sorry. But all the best boot camps in the world, this is our jobs. Richie, you had the schedule of the boot camp, especially if you're a full participant at the boot camp. The schedule is there that will be here at this time now. The schedule is there, so it's not like something changed in the schedule. Okay. In fact, my internet went off. I'm just back to. The session for 3:30 has begun. Anomaly detection. You can click on the breakout rooms on your screen, depending on the device that you're using, and you can join the class. It's by Professor Thomas. Matter, balance. I'm serious, it happens. And it happens to everyone in the world. About network challenges to important meetings this year, but in Nigerian parlance, we bless the Lord. Yes, you can be in a detection class and click on the breakout room and join anomaly detection. But we'll come and look for you. This is an interesting class too. Exactly. So I can see it in the chat window. Yes, please, anomaly detection to look for you when we are. Okay. Okay.
I'm back. Can you hear me now?
Oh, yeah, it's back. All right.
Yes, I can hear you. Please share your screen.
Yeah.
Okay.
I don't have a couple of things are not available. I'm joining from my personal laptop now. But you should be able to one or two things may not be available.
Well, you're quite audible now. It's clear. You're sharing your entire screen and I can see you're going to the applied AI slides.
Okay, good.
Okay.
Very nice. I think it's probably the problem with the Zoom application.
Wow. Okay. Okay. We were on this page.
I think we followed this. Yeah, we are here, I think. Okay. Yes, I think you got the idea of how a project get implemented in a machine learning environment from inception up to a production. I think this is where I stop, right?
Yes, that was where you stopped and you can continue from here.
Okay. And is there any, audience has any question? Is there any questions in the chat bot or in the chat box?
Okay, for now, we don't have questions. What you have is welcome back messages for people that have been waiting. So, so please, let's continue.
Okay, very
Tim,
good.
if you have questions, please put it in the chat window.
Okay, so now we'll start a little bit on the. I'll show you one of the Google Colab on some applications of how to get started with TensorFlow, etc. But this is just an example, very basic example of how a digit classification works. It's a very common example. You probably have seen it. I'm not going to go through this in detail. This is just to get up. This is a very simple classification problem. You have pixel coming in, and the pixel is this 28 by 28 pixel. And the first step is to actually do the flattening of the pixel so that it becomes a cell, and then 784 pixel, and then flat, you have bunch of classes like 0 to 9. Those are the possible classes, and we apply some of this classification. Here is a softmax function that is going to convert the input into the output. That is what is going on, and we have some combination of weights and biases that is going to be decided by an iterative algorithm. That's pretty much what is going on behind the scene. This is a kind of one of the example of that, how that happens. So that this is the input on the left-hand side, and you have some of the weights in the middle, and then it's kind of a cross product of inputs and the weights. And intermediate layers also have a bias. So this is every little neural network, and what you see on top of it is variations. You use number of layers to have more accuracy, or depending on the number of records, you have more and more layers. And there are other concepts like how do you reduce overfitting, underfitting, things like that. So that's what is going on here. Okay. So one, it is going on, and this is a simple application of the equation. As you see, it is a very general algorithm. But most important thing is here, like how do you know when to actually stop the process of training your data? And that is where we have to decide on the success factor. And one of the ways to do that is to compare your actual result with computed result, computed output, and use some kind of function to decide that. This is one example. Is cross entropy is one of the ways you can see the distance between the actual output and the computed output. And then you kind of iterate through that and make sure this is minimized. This error between the actual and the computed is minimized. And that's how you a concept of gradient descent, because gradient, don't worry about it. This is something you can always learn by going through any basic course. But the most important thing here is that I need to optimize my output. I need to reduce my error in the output. And there is a concept of gradient descent is an optimizer that is going to help us getting to the right results quickly. That's what it's really going on. And this is a complete Python code. So it has a couple of components. One is you have to initialize TensorFlow, like import tensor functions, then following by that creating a model, like softmax function that you apply to create the model, and then you figure out what is your success metrics. And there is a fancy name for that. It's called loss function. And then loss function is getting, then you optimize that loss function and using the training step. And that's what is showing on the right-hand side. Then you run this and the model gets created, and then you can deploy the model with your test data. So now what happens when this training is happening? So what is happening is you take the batch of your data, and that batch means you have X and Y, you have of X, and you have your targets. You run the network to obtain the predictions, and then you compute the loss functions on the batch. There's a mismatch between the actual output and predicted output. You update all the weights of the network in the way that slightly reduces the loss of the batch. That's pretty much what is going on. This is another representation of that, but that's pretty much, you are basically changing the weights so that loss function is minimized. So there's one concept that you want to understand, or it'd be important for most of the practical application, is this concept of pre-processing. There are many pre-processing you have to do in many cases. However, a lot of the programming APIs like Keras, etc., they take care of a lot of these capabilities, and they have a lot of functions and libraries to get you started quickly. So one of the things that you have to do in many machine learning systems is one-hot encoding. That means it's instead of using, because it's all about math, you need to convert any kind of categorical data. Categorical data means phrases or words like headache, fever, rashes. These are the example of the word. We need to convert this categorical data into a presentation. So almost every one of these values will become a column in your table. And then depending on where somebody has that particular category, you just say 1 or 0. If somebody has, let's say here, you're trying to figure out who has headache, who has fever. So in this case, all the actual values of the category will become the column, will become the attribute in the model. And then you either say 1 or 0. So this is one of the steps you need to do before you apply your data to the model. And there is a concept of confusion matrix that is generally used to evaluate your model. And there's a 2x2 matrix where you have your answer or correct answer versus the predicted answer, and there's either either you have the true positive or false positive, false negative, and the true negative. And these are the things you can always learn going through the course. I'm just going to give you an idea, things that you want to learn if you don't know already, like a concept of one-hot encoding, concept of confusion matrix. But I'm not going to go through this because these are already covered in most of the machine learning courses. And now I'm going to give you some example. So let's go through one example. Can you see my screen?
Yes, we can see your screen.
So here, there's an example of a natural language processing foundations. Natural language processing is a very big area where, idea is to extract information from an unstructured text. There's a couple of things you could do from there. You can extract various entities. Entities mean nouns or verb, etc., from that particular text, or you can modify a text. Whether reading at the text, you know whether somebody is saying somebody's angry or somebody is happy. So you can derive a lot of the classifications from the text. Or in many advanced cases of NLP, can generate text for you. But I'm not going to go through all the things here. I'm going to give you a very basic example of how to get started with this kind of problem. So here, what I'm doing, you're just calling, importing the TensorFlow, and then I'm also importing some TensorFlow data sets just to give you an example. And most importantly to note here, see, I'm going to use Keras. Instead of using basic TensorFlow, I'm going to use specifically the pre-processing, text pre-processing module of Keras that has a function called tokenizer. Tokenizer is a concept in NLP where you convert a set of sentence or set of your text into individual pieces of word and phrases. And then you convert that word into a specific number. You map to a number, because when you do this kind of processing using machine learning or using TensorFlow, they expect you to have a number. You cannot process an individual word in a TensorFlow. You need to map individual word to a number. And that's what I'm going to show how to do it. So for example, here, I just wrote a sentence. It's called set of sentence. Today, is it a sunny day? And then you have a completely different sentence. I really enjoyed walking in the snow day. So now I have to convert this sentence into tokens. And how do I do that? In regular TensorFlow, I probably have to write 10 to 20 lines. Here, I just to write 3 lines. I just call the tokenizer that is available in my Keras module, and I just say fit on my text. I just give the sentences that I need to tokenize, and then I all the corresponding numerical index for my words. For example, when I print this output, I see every word now has a corresponding number. That today is 1, is 2, is 3, sun is 4, day is 5, and then rainy is 6, and then so on and so forth. Now, looking at this, you can also see, if you compare sentence number 1 and sentence number 2, like today is a sunny day, today is a rainy day, that will have very similar number as well, like 1, 2, 3, 4, 5, 1, 2, 6, 4, 5. So if you now compare those two sentences, you'll see that those two sentences will be similar. If you just do distance calculation between those two sentences, those sentences will look like very similar. So that's one of the ways we do a lot of clustering, a lot of similarity analysis. Once you convert this kind of sentences into index. And this is the way now it will look like. If you now print the sequence of sentence I had, it is going to look like 1, 2, 3, 4, 5, 1, 2, 3, 6, 5. And that is the representation now I can pass on to TensorFlow. But there's a bunch of other things you do here, like I padded it because I need to have a consistent length. And then another concept is I want to remove some of the stop words. Like I don't want a, and, etc. in my analysis, because those may not add much value. In some cases, it adds value. But in case of, let's say you are doing sentiment analysis, those a, and, etc. will not add much value. So it's better to remove those stop words and not add the noise in your data. So for that, what you do is you just download some kind of words that are stop words. Like for example, here I just written down some of the stop words. That is generally the stop words, like above, after, again, etc. And then I'm going to use a simple function to remove the stop words from my sentences. And I'm going to go to all the data, but basically what you have to do is, once you have the data in your place, you can go through some of the basic functions and create the output that is without any stop words, without any punctuation, etc., other noises that you have in your data. But all the, and then you see something like this. But the basic stuff is here, that this is the fundamental that is used in pretty much every natural language processing algorithms. And this is a sophisticated version of it. So now I only had 5 sentences. And instead of 5 sentences, I can use whole Wikipedia, or I can use whole medical text that is available on the internet for medical specific applications. So that would be my data that would be used for my training. So in this techniques, a lot of people, a lot of researchers has created lots of large data sets, and they already created those indexes for us. And you can download those and then use it instead of you are starting from the scratch for your application. And there is a significant variation, significant research that is done in Google and outside of Google in this space. There's a newer concept called attention models, GPT-3 you probably heard of. These are all variations of this simple concept of creating indexes from the word. There's one more thing they did in this recent advancement of this concept of NLP, is that not only index the word, they also find the meaning in the word, and then have a word embedding that is going to have similar words. So that, let's say, what is the relationship between king and the man versus queen and woman? So I want to have my word model or language and those kind of nuances in the language. And so that I don't have to say to my model, let's have let's understand this meaning, because those are meaning can be derived from the various English literature or any other language literature. I'll tell you one interesting application that happens in a healthcare field because of this interesting development. So what happens in medicine, you have a lot of different ways people can talk about a single single medication or drug, or they can talk about different ways of expressing the same concept. For example, I say that this is myocardial infarction, and nobody knows what the myocardial infarction is unless you're a doctor. But the actual meaning of myocardial infarction is heart attack. So now, if my word embedding can tell me that these two actually related, because this is used interchangeably in medical language, then my application will know, yes, when somebody is talking about myocardial infarction, they're actually talking about heart attack. So now, because of this concept of embedding, now I can do this kind of applications automatically using some of the NLP techniques. My presentation, I'll come back here after a couple of iterations. But there's a couple of other examples here, you can that you can look at later on. And this is a movie review applications where it's a very similar thing. I'm using Keras, and this is something done by my colleague. I haven't done this. I just copied their models. And here you can see that it's the same concept. I'm downloading some data, and then I'm going through this kind of indexing, preparing the data that way, and then applying the training, and then doing the trainings on this, and then basically building a neural network, dense neural network like this, like you see here, and then compiling the model, and then optimizing the model, and the validating the model using test data, and then basically then using the deploying the model in a some kind of setting. So this is a general approach followed, and you can see here using Keras is going to help you do these things by writing less lines of code, because it's already doing a lot of the work for you, so that you can do this without knowing a lot of the mathematics that is going on behind the scene. So now let me go back here. Here I have an example of movie classification, there are example of tagging a new article, etc., and predicting the house price. And the source code is available here. I'll make the presentation available to you, and you can look at it. But I have to move on because I don't have enough time left. So in terms of the workflow, now we can summarize the workflow. You have data. You have to design some kind of Keras estimator. That is, we are designing your model using some of the functions available in Keras. And then you start your training. You can do your training in your laptop, or you can do distributed training in your Colab environment or in a cloud environment. And then you save the model. You then move to some kind of model repository. And then there's another part is deployment. And I haven't shown it here, where the deployment is an important part as well, where you can use TensorFlow serving infrastructure to deploy your model. But there are other variations of this deployment available as well, like TensorFlow Lite. There is a concept called TensorFlow JS, where you can actually develop applications in your mobile phone using the model that is created. And there are a lot of work on that going on right now as well, because running something on the mobile platform is totally different than running a model in your laptop or in the cloud, because mobile doesn't have a lot of the power that cloud has. But you still need to use it because some of the applications will require that kind of environment. And one thing I don't know whether all of you know, everybody has access to Colab. If you have a Google email ID or Google ID, then you can just go here and then say more, and then Google Colab Laboratory is available for everyone. And this is actually behind the scene, it's a cloud. Behind the scene, it's Google Cloud, and it's free. So you want to take advantage of that. If you see here, I can connect to host, and I'll be connecting to a 2 CPU machine in Google Cloud. So it's a huge advantage for anybody who wants to try something and then you don't want to use cloud directly, but this is actually an open platform and the cloud is happening behind the scene. And there is a professional version of this. I think that's the paid version, but you can get started with this version as well. This is same, they have a lot of capabilities. For example, there's one thing is here, I'll tell you, you can actually use various, there's a one place here I can actually, hold on, let me see. You can actually go and apply TPUs as well. Change runtime type, I think. Hardware, yeah. You can use GPU, you can use TPU as a part of this free version as well. Of course, there is a limit, but if you need it, you can use TPU, GPU, etc., just going through this free Colab, and definitely want to take advantage of that. So now let's move on to next topic, which will be much more interesting in my mind. That's building and implementing AI project, and I'll give you an example from healthcare industry. Obviously, what is the workflow in an AI project? Now you've done this, you probably have now a little bit idea about what the workflow looks like. You have to collect data, first of all, and the data could be available as a part of your data warehouse. If you are in a business organization, it may be some kind of transaction system you have that may have data as well. But then data might not have label, like we have about X and Y. So Y may not be available in some situation where you have to use manually have to do the labeling. For example, the diabetic retinopathy cases, we have to get the radiologist to do the labeling. In some cases, you may not have that flexibility. Those are expensive process sometimes. So we have to use some of the labeled data already available, or you can use some of the unsupervised machine learning algorithms to create your label as well. Then you train the model, you evaluate the model and test the performance and iterate the model. And then you deploy the model in production environment, monitoring performance and maintain the update the model. So that's pretty much the workflow in any kind of AI project. Doesn't matter whether it's doing speech recognition or you're doing medical imaging. And where cases the ML has a big impact in industries. I think we already talked about some of these things. Like you have expertise is limited, where I do not have radiologists available in all countries or maybe all regions of the country. Lots of data to look through. A lot of the data is created as a part of routine transaction. Let's say somebody goes to a hospital, there's data that is created about the patient, admission, then you have data around patient lab test, observations, medical images. There's so much data available that you could potentially have get access to. One challenge is because of the privacy and security and other reasons, you may not have access to all the data, but it is potentially those data sets could be made available in a variety of secure ways. And the last thing is very important. Predictions has to be actionable. Whatever you do predictions, that should be used for decision making. For example, when I'm predicting somebody has a diabetic retinopathy, then there must be a doctor who is available to tell the patient what to do when you have a suspicion of diabetic retinopathy. If that step is not happening, then all the prediction, all the ML work will not have any meaning. So how do you evaluate an ML solution in a practical environment? There is only 3 ways to generally do it. First, utility of the model. What is the purpose of the model? What task the model is going to automate? The second one is feasibility. ML should be able to solve the problem. ML cannot solve everything. And ML should be able to integrate with current workflow of a physician's office, or maybe the IT application that physician is already using. That model of diabetic retinopathy has to be integrated with that particular application. Otherwise, the people may not be use another application just for this purpose. The third one is impact. When I'm creating this model, I need to have a business outcome, because you are from a business environment. People are going to ask why you are actually doing it. It has to increase your revenue, or help you launch a new product, or your customer experience and operational efficiency, and so on. So before you start the project, what are the things you could do in order to make sure you are in the right path? There are some due diligence you have to do with starting an AI project, starting an ML project. For example, that problem you are having is very specific. You need to be a clear understanding of the task that you are trying to automate, whether it is detecting diabetic neuropathy, or detecting cancer using MRI images, or any other thing that you want to do. And there has to be a sufficient number of examples with consistent answers. And you don't have to have large, big data all the time, but you have to have consistent, true answers. Like, for example, in our case, diabetic retinopathy, we validated with various radiologists, and the label has to be accurate in most instances. Then success. Have a clear success metric, because you may say, I want 100% accuracy. That may not be practical with the current ML models, but it may be possible to have 95% accuracy. So you need to have a clear expectations that some of the cases might not be automated because of this. Maybe 5% of the cases has to be human driven than automation driven. Next one is a value. Assuming you have the success, what is the value to the business? We already talked about it. Then integration with the workflow, IT workflow, and etc. So now these are examples. What are some of the examples? We already discussed a lot of examples. This is the example from my for example, what is the likely length of stay of a particular patient in a hospital? This is the patient right now. Highest risk of coming back to hospital in next 6 months, or maybe who is going to visit Eddie. So these are the things we're actually doing many of our customers. And I'll give you some good idea about you can it. What kind of questions you should ask to evaluate beyond the performance. Performance is good. You know the accuracy of the model, you know ROC card, score, etc. Evaluate the effectiveness of a model. And I'll walk you through why that's not the case. So for example, you say, I have a best model to predict the readmission of a patient or predicting the disease condition of a patient. But it's important to understand what data is used for deriving this prediction or prediction. For example, here, the data that should be used for this kind of model is the historical data of the patient and also data that is derived when somebody is at the hospital. And then you have either you have two models. One is a readmission, should be within hours or days or months, because if you have too much, then that model will not have an effect on the business. But if something called renal failure, which is happening maybe later, not now, and that is also okay, and that prediction may not be accurate to me right now, but I still need to know whether this patient is likely to have renal failure in the 5 years so that I can have an interventions right now.
Monica.
So basically, there are three different criteria you can use to figure out whether the model is effective. One is who will receive the insights, what that person is supposed to do with that. Then is the person and group capable of making the decision? Also, some institutions, to the doctor, if that person is responsible, if this person is the decision maker, and the persona of the individual is really, really important. Now, there is another thing that comes into picture in a business and whether you should buy a model or you should build a model. You know, the general advice is avoid things that is becoming an industry standard. For example, natural language processing is a point for you to start a natural language model from the scratch. You can always take the model and then uptrain it. You can create your own model, etc. But starting from the scratch is probably not a good choice. However, there are some unique model specific to your business, maybe for your retail business that you have or the healthcare business you have. You can build some unique models using the unique data that you have in your organization. And that will have a more significant impact than creating a conversation model. So that's a general idea about how to choose a project, how to choose model, etc. Understanding of the data and nuances of the data in practical environment. There are several issues like what kind of data you have, data types. Then you have that data normalization problem because a lot of data coming from different sources and they may not be normalized. And then you have the issue of unstructured data, that you've shown, conversation, text, etc. Then you have the issue of data quality. Data is really good or not. And other issues like bias. And then you have to label the data. There's a lot of practical issues to worry about beyond the math part of machine learning. And obviously, there are a variety of data. This is where I'm showing you different healthcare data that is available. And there's a lot of different formats, even in the structured data. And then you have data that is coming from lab results, coming from notes, which is unstructured. Then you have medical signal. All of these are the good data sources. So one of the initiatives that is going on in the healthcare industry right now is a normalization of the data to standard representation. This is called FIRE, but I not bore you with that, but there's an initiative going on right now to normalization of the data in a single good format so that application and machine learning developer can work from a single format and worry about multiple formats of data. But that's it. The point is you have to do some kind of standardization of data, some kind of unification of data. That's why having a data warehouse or normalized data warehouse is really important for machine learning purposes. And in some industries also have knowledge graph. That means you have a lot of the, for example of knowledge graph is, knowledge graph of name of the disease and relationship between the disease, relationship between disease and patients, and the concept of what I talked about. And some of this available open source. A lot of researcher out of NIH has done significant amount of work for the last 20 years to develop this kind of knowledge graph for medicine. But for your industry, this knowledge graph may not exist. So we have to create this kind of knowledge graph for your environment. Simple example of knowledge graph is creating synonyms or creating abbreviations of certain words. That's an example of a knowledge graph. This is the example. I'm just going to skip all these things. Now let's move on to the concept of this data quality. And there are the conformance. The second one is accuracy. And third one is data distribution. Conformance is whether values are correct. If I'm expecting numerical value, that field should have numerical value. If I'm expecting in a certain schema in the my record, that's a record has that schema. That's the easy part. But then once I have the data, I have to figure out whether the data is accurate or not. Let's say there is a field called discharge time. And some cases discharge time is there, sometimes is not there. The value sometimes doesn't look good. So that's something to verify. And then whether the data is really good, even if you have data, like you have the temperature value, but you have the temperature value, let's say, 300 degrees Fahrenheit, which may not make sense in most cases. Then you have the data distribution problem. This is actually one of the biggest issue in machine learning that you have to be aware of. And when you are designing your algorithm, because let's say you get data from medical system A, from organization 1, and then you get another data set that you have from hospital number 1, maybe for a very senior patients, aged patients. Now that model you create for readmission or any other thing from that hospital may not apply to the second hospital. The second hospital may be the pediatric hospital, maybe the hospital where most of the population is less than 50 years old. So that but that model now does not apply to that hospital patients. So these are some of the things that challenging things that comes into because of the data distribution different than data distribution in the second source. And then another issue that you have to worry about in practical application is this concept of bias. And bias is a very complex problem, but I'm going to walk you through a scenario, and you'll see there are so many biases, even in this simple example. For example, let's say patient is admitted in a hospital, and patient has certain illness. But it is possible that patient is coming to hospital because this patient has insurance, patient has money. It is possible that you are missing the patients who is ill, but who may not have money to come to hospital. So that's a problem if you want to be creating models for everyone. The second one is, let's say now they come to hospital and there is a diagnostic, there is a prescription, there is an exam. However, let's say, even somebody comes to hospital, I don't do all these things. I may say, I know already you have a disease, you have pneumonia. I don't have to do those exams. But other cases, I have to do exams. So exams are not mandatory. So that's like a classification bias. And then whether you are entering data in EMR correctly or data is. So let's say the data is in a document and you only have access to the EMR structured data, and that will create bias as well because we're missing a lot of details. Now, let's say you go through hospital and then hospital submits a claim to your insurance company. Again, that is also a selection bias because not everybody has insurance. So you can see just a simple example, there are so many biases that is possible. So if you are just selecting based on a single condition, whether somebody has a disease or not or symptom or not, you will miss many things, many patients in the process. How to overcome this bias? What is the part of the issue? How do I solve this problem? So one of the ways we're thinking of in our project is to verify across multiple resources. If somebody says I have a disease, don't just believe that. Do a lab test. Get data on the lab test. Get data on the medications so that you can confirm that yes, somebody is going through the lab test, which is very similar to the lab test a pneumonia patient will go through. So, and then medication, somebody's taking the pneumonia medications. So there's a verification you can do across multiple sources. And the second important thing is you can combine multiple sources, like combine structured data from EHR systems to the scanned documents, etc., so that you have complete picture of the patient. And maybe in some cases, you have to go back and see who is not coming to hospital in your community. That would be a good data source as well. And then maintain the lineage of the data. You need to make sure when you're designing your pipeline, data pipeline, you are maintaining the logs of what you had actually done on the data, where from you got the data, what kind of process you run, etc. So now you know a little bit about what kind of issues that I have to worry about while creating a model. And let's do a quick rundown of how to actually create an ML-ready data from a regular database. Here, I'm going to walk you through the bunch of steps here that is used in the healthcare industry, but this is similar steps could be utilized for other industries as well. First what you do is unification standardization of your data. If you don't standardize everything, that's okay, but at least some kind of standardization and unification is required. Basically, you're getting the data from data warehouse or some of your transaction systems, and then you're kind of ordering those in a time fashion in your data, in your ML data. And this is what I'm showing you, the patient timeline, where you have patient encounter, labs, vital signs. There's so many different kinds of data that you could receive corresponding to your patient. Then you have to define what is the prediction task, what you're actually predicting, for whom you are predicting. Is it for the senior population, or is it for the pediatric child population, etc.? When are you predicting? What is the prediction time that we mentioned before? Is it hour from now, a day from now, or years from now? What is the prediction time frame? And what is the outcome you're predicting? What is your label? So here in this case, the example of label is length of stay. When somebody gets admitted to hospital, what is the length of stay for that particular patient? That means you have to find out, when will this patient leave the hospital? The answer is all the patients who is going to predict who it is for. It is for the patients who have been admitted to the hospital for the last 24 hours. When are we predicting? 24 hours after admission, for example. And what's the outcome? It could be in a days, or could be a class of days, like 1 to 3, 3 to 7, 7 to 14, etc. And then there's an example of how to create a label from a database table. You don't have to always take the label from a manually go and do it, but you can actually derive from database as well. That's the advantage of having big data. And then you do the cohort selection. That means set of patients that satisfied a particular condition. For example, if you want to find diabetic patient, there is a standard definition of diabetic patient: HbA1c, count of glucose test, other criteria. This is an example of how do you use a database table to do your cohort selection. And then sometimes you have to create new features. There's an example of features is, there are a lot of categorical values available in medicine, like procedure code, medication code, etc. Those are very detailed. You may not want all the detail in your model. You just maybe need a medication class. Like, instead of figuring out what actual antibiotic you have, you probably just want to know for your model, whether somebody is taking an antibiotic or not. So that means you just want to aggregate the medication. That's an example. Or scoring data, whether how many disease somebody has currently. Is it just a diabetes, or the person has heart failure or other kinds of disease? So that, based on that, I may have to score a patient differently. And then you can add some context to the data. For example, socioeconomic data, public information around the patient. One of the things that is going right now is to understand the patient economic situation, because that affects their health. So if you're predicting without understanding the economic situation of the patient, that prediction might not be useful. So you have to add that context in your model so you take care of this kind of conditions. So now, you got some understanding of how complex it is could be to implement an AI project. But let's start with this, how do you actually start? Because this looks like a lot of work, right? And before I do that, I got an interest a slide from Andrew Neg, who is a famous professor of machine learning at Stanford. He's giving a lecture and he was talking about how to really become an AI-enabled organization. And he has really had a good anecdote that I want to describe here. Like internet era, if you have a shopping mall and website, that doesn't mean you are an internet company. Amazon does more than just a website. There's a lot of stuff going on like A/B testing, statistical analysis, iterative product development process, and more importantly, decision-making pushed down to engineers and specialized roles. AI era in your organizations or any organizations is the same. Like just deep learning is not going to change any organization. There's a lot of things that we talked about today is very important, like data acquisition, data collection, understanding of the, having a unified data platform, like unified data warehouse, and some kind of automations around that. Important before somebody can become a AI organization. So how do you start? You don't have to start by spending the next 2 years creating your data warehouse. You can start with the business problem for a particular service line, a particular division, and do a MVP, do some MVP to production for a particular setting, a particular problem, and then repeat and scale across multiple lines. It is very important to have some success within 6 months of your project so that you can continuously get funded, you can create some excitement. That once you have those things, then you can think about creating an in-house team, creating a data warehouse and platforms, provide a lot of training for your people, or maybe create an AI-assisted business model, have a business strategy around AI, how are you going to serve your patients better, or how you create new revenue stream, etc. And of course, then you have to create some good internal, external communication to make sure people understand your AI strategy. And there are several roles in AI project. This is a typical project in an organization like Google, but other organizations possibly follow very similar things. Like there's no concept of like a one data science role. Generally, this is divided into multiple roles. Like you need a software engineer who can code the application. You need a machine learning engineer who can create models in the pipeline. You need data engineer who can create the data warehouse. Then you need a data science role who could examine data and provide insights from the data. And you possibly need a machine learning researcher, a machine learning scientist who can understand the next generation of state-of-the-art models. And then lastly, you need an AI product manager who can decide what to build, what is feasible or not. And then you need a UX designer who can design the user experience. In some cases, some of these roles have collapsed, like a data science can take on role for multiple responsibilities. But this is a kind of general ideas about, what are the kind of skill set you might need in a machine learning project. So now I want to, I think I have, I'm just going to time check a little bit and take some break. Do you have a little bit more time, or I have to stop in 10 minutes?
Hello.
Yeah.
Okay, we would have to stop in about 10 minutes. This is till 5.
Okay. Okay, very good. Yeah. Okay.
Okay, so we have some questions in the chat window. I don't know when you'll be ready to take some of them.
Let me take some of this right now because it will give some break also because I'm talking too much. I think. Let's take some
Okay.
break and yeah.
Okay. So Favor James is asking, sir, if someone is not in the healthcare sector, like an engineer, can the person be involved in creating solutions related to healthcare?
Yeah, I think that is exactly the, or talk about some of the skill set you require in a creating a machine learning project, and we need skills from variety of different background, because if you just have skill from only people from one particular background and people just work in healthcare, that person may not have insights into what is going on, what is possible in retail, what is possible in automotive. A lot of ideas actually come from outside of industry. So having a people outside of that is actually going to be very valuable for a sector or maybe for any sector. So I want to use that as an advantage than as a drawback. But once you join the team, you have to spend some time reading about healthcare or experiencing about healthcare. I'll give you one concrete thing that I have done, because I came from normal engineering background. I did not have healthcare background 10 years ago. So what I did is I just visited a lot of hospitals. I just sat in the emergency room. I see what people are doing, and I also got approval from a physician to shadow him for 48 hours so that I know what exactly they're doing. So that way I learned, like within 48 hours, I was more educated than healthcare than pretty much people who probably worked in this for a year. Not the technique you can healthcare industry in general, but healthcare is easy to learn because everybody has parents or children who need some kind of care. So if you get interested in their health, you learn more. If you don't have that, visit a hospital for a couple of days. You learn pretty much a lot of things you need to learn in order to get you going.
Okay.
Any other question?
Okay, if you have more questions, there's a question about where can I get models on NLP? What does this question mean? Do you mean pre-trained models? Do you mean pre-made collaboratory notebook? If you're online, kindly respond on the chat window. But the question says, where can I get models on NLP?
Yeah, in general, there are a couple of ways you can do it. So one is there are APIs available from Google Cloud or other cloud vendor where you can just use that as an API. Like you give an input, it will give you an output, so you don't have to do any model. So that's one way of approaching it. If you are not an NLP expert and you just want to use it for your business, that's one way to approach it. The second way is use BART or other models that is open sourced by Google. So Google open sourced, or other companies also open source many models that could be a starting point for you. For example, the word embeddings, etc. You don't know how to create yourself. You just want to download all those things. I can send you the link, add a link in the presentation about where to find this information, but there's lots of open information available. Even if you go to tensorflow.org website, you'll see the list of those links where NLP models are available and that you can get started with.
Okay. If you have more questions, the floor is open for you to ask in the chat window. Okay, so he has answered that. Go to tensorflow.org,
okay.
Play around. There's you can play around, see some of these things. Just play around.
Yeah.
Okay.
Yeah.
Do we have more questions? Okay, I'm listening. We're listening.
Okay, so let's finish it a little bit. I just want to finish it the next 10 minutes, and then we can have more questions, and you can send me questions later on as well. I'll try to answer as much as possible. I'll also send you the presentation. I just want to give you a state of the art, what is going on in this natural language processing, which is a very active domain at this time. If you are entering, machine learning at this stage, there are two general areas which are very hot. One is image processing, and that happened in 2012 and 2014. But if you're entering now, NLP speech recognition is a very exciting area to develop applications on. But of course, there's a lot of others, but these are the two very emerging areas. And what is going on is right now, conversation is becoming a new AI, new UI. Like people are, mobile applications are becoming conversation driven. And then, you want to have a good conversational experience. Either it is a voice bot or there is a chat interface. And that is where a lot of the natural language understanding or natural language processing, AIs are used. And there are a lot of different acronyms here that you want to get understanding of. NLP versus NLU versus ASR, versus TTS, SST. There's a lot of acronyms. You just go and, you can just learn all those things. Just going to the Tensorflow site. But main thing I want to show you is what does it take to build a good conversational experience. So the first thing is in the conversational experience is understanding of the intents. That means understanding of what I want, like a verb. I need coffee. My laptop is broken. Tell me, I'm pretty, something like that. So these are the things are intent, and the conversation or your model has to understand these intents. And then second one is entity. Entity basically noun. Name of a disease, name of a person is an entity. And the third one is context. Once you understand the intent and the entities, you have to understand the context. Like you're saying, a flight from Los Angeles to Hawaii for less than 300. So that means it is saying the context is somebody wants to book a flight and somebody wants to do it. There's a within particular limit, and then this is some of the ways the NLP model will understand what they're supposed to do. And there is a lot of tools available within Google environment and also other cloud environment as well to create this kind of stuff automatically for you, so that you're not spending too much time on this. Of course, you can develop your own model as well, but there's a significant amount of work involved. If you see here, there's a lot of integration involved on the front end, or integration involving understanding the intents, understanding the context, but it also, there's a back-end fulfillment pieces. But once you understand the intent, then you have to go to the database or go to some other API and applications and actually book the flight. So now if you think about a chatbot system, that's a fairly complex system. You have front-end activities, then you have the back-end activities. And this is where you can spend more of your time. Instead of trying to create a speech model, trying to create an NLP model, your time might be better served by creating these AI-driven application, which is fairly complex. You can create a lot of IP out of this work as well. And there are some of the tools. You can go to Google website, Google Cloud website to learn about these tools. Like a Dialogflow is a tool from Google Cloud that is used for this kind of development of the chatbot, voice bot, and also how do we orchestrate the fulfillment to the backend. So I'm going to just skip through that. Yeah, I had some demo around it, but I don't need to do that now. That's okay. So the point is there's a significant amount of work involved in just, beyond creating the model. That's what I want to demonstrate here, that just creating the model is not the end game. There's a lot of things you can do beyond just creating the models. Now let's Google Cloud AI tools. There's a lot of things you have. I talked about pre-trained API. You can do AutoML, or you can do end-to-end AI using the tools of TensorFlow, etc. And there are tools for everyone. You don't have to be an expert in order to start machine learning, in order to start TensorFlow. There's a tools available to get you started just with API. And then, most important other things also, there's ethics. Ethics is very important. You want to create models that is important for the society in general, or it's not going to create harm. So there's some Google created a lot of AI principles that you can review that is like a socially beneficial. You should avoid unfair bias, built and tested for safety, it's accountable to people, incorporate the privacy design principle, and uphold the scientific excellence and things like that. And we also identify as a part of this AI principle, what are some of the projects that Google will not get involved, like principal injure or war type of situation. So those are the principles that we created, and you can use this and create your own for your organizations. Like most important thing is, and make sure that data does not have unfair bias. This is a huge problem right now. And we are actively working to check the algorithms to make sure that doesn't have the unfair bias. And obviously there are many, and there's a lot of work that is going on, but especially in healthcare settings or the social settings, this is really, really important, and even for the business. That's what I have for today. Sorry for all the interruption, but hopefully this was useful and you learned something new. And I'm going to send you the presentation also so that you can look at the links and review the presentation later. Any other questions?
Yes, there's a question about from someone that said, I've used scikit before. How do I learn TensorFlow? Like scikit-learn.
Yeah.
Now,
so I think if you know scikit-learn, learning TensorFlow will not be that difficult. The concepts are exactly similar. So I would recommend start with Keras, keras.io. Go to keras.io and do some of the example collab, example notebooks. Don't just copy and paste. Try to write your own code. Look at the code in one screen and write the code in a second screen so that you'll get used to writing code in a different language. That way you can use your concept, but then you can learn the syntax. That's the fastest way to learn in my mind. But you can use other topics as well. There's a lot of courses available in tensorflow.org has a lot of tutorial. But the trick, if you want to learn fastest, copy and paste. Don't copy and paste. Copy and write yourself by going to keras.io website. Next question. I see there's a question on deploy a chatbot with learning more of software. So I think the simplest way to deploy chatbot is to use some existing
Hi, Wura. Your connection is.
Yeah, some reason I'm not able to, there's some echo coming.
Okay. Let's see. Wura, can you hear me?
Yeah, I can hear you, but there's some noise coming.
Okay, sorry about that, Dr. Adrish. Please, you can go ahead with answering the question.
Yeah. So what is the next question I see? Hold on. Let me see. There's a question of learning PyTorch versus learning TensorFlow. I think you can learn either of the model. You know, it doesn't matter. Both has functionality. TensorFlow and PyTorch both are popular and have very similar functions. It doesn't matter too much. But if you both has good function, good libraries. What about learning Spacey? What recommendation can you give? I'm not familiar with that much of Spacey. If it is a Python one, the challenge with just using scikit-learn or Python is very difficult to implement in a real life large environment. That is one of the advantage of distributed models like TensorFlow, like PyTorch. It's much more easier to scale. But you can start with anything. But if you want to looking for scalable application, then TensorFlow or PyTorch, those are the most popular or most used.
Okay, thank you, Dr. Adrish. I think they.
Can we get a? Is there any other questions?
There is one question, I think one final question that says, can we get a practical implementation in Python of speech recognition or audio classification?
Always create your speech recognition model. If you have audio data and then you have the training data, like you need an audio file and then you need a corresponding input, and then you can create your own model in Python. And I think TensorFlow is using Python as a language, so you can use that as a way to get started.
Yeah, thank you very, very much. Can you hear me? Hello? Can anyone hear me? Mic check.